Welcome back to Join Mathematics. Now let's solve the exercise that we're given in our previous lesson. We're asked to represent the vectors in the form x, y. And we had vectors OA, vectors OB, vector OC, we have vector OD, and likewise we had EF, GH, and IJ. Now we are familiar with OA, OB, OC, and OD. So let's solve that quickly. Now OA, we just have to look for the position or the coordinate of A. The coordinate of A is simply 2, 6. Okay, or sorry, should be 6, 2 because we are dealing with x, y. So 6, 2. Therefore, the corresponding position vector OA is 6, 2. Also, B, all we have to look for is the coordinate of B. The coordinate of B here is 1, 6, and OB therefore will be 1, 6. You can see how easy it is. And moving on to C, we have to look for the coordinate of C. The coordinate of C here is -4, 6, and OC, which is the position vector of C, is equal to -4, 6. Moving on, we have OD. So the coordinate of D from the graph is -5, -5. Therefore, we can simply say that the position vector OD is written as -5, -5. Now, we want to solve the more tedious questions. We have EF, okay, we have GH, we have IJ. There's no doubt we're able to solve OA, OB, OC, OD correctly. Now let's move on to EF. Now for EF, now we just have to evaluate the coordinate of both sections. The coordinate of E now is 1, 1, and moving on, the coordinate of F is 4, okay, 6. So now let's move on there. Now we have EF. Want to evaluate the vector EF, that means it's moving from E, okay, down to F. So E is the initial position, and F is the final position. Now the initial coordinate, which is E, is 1, 1. The final coordinate is 4, 6. Now we can call this x1, y1. We can call this x2, okay, y2. Now the simple way to evaluate the vector, all right, of this line segment EF, you just have to say x2, because x is at the numerator, or let's say at the top, not the numerator since it's not a fraction, and y2 minus y1. So we have line segment EF or vector EF now. So x2 now is what? 4. Y1 is what? 1. Y2 6, and likewise y1 is 1. 6 minus 1. So when we solve this, we'll have EF, the vector, to give us 3, 5. Now we can compare this and saying that, oh, instead of going through that stress, we'll just evaluate how many boxes on the x-axis. On the x-axis we have 3 boxes, 1, 2, 3. Okay, and on the y-axis we also have 5 now, 1, 2, 3, 4, 5. So we have 3 on the x-axis, and then we have 5 on the y-axis. So let's rewrite this and say the line segment of EF is 3, 5. Now we have solved for EF. Let's solve for GH. Now solving for GH now, we just have to evaluate the coordinate of G and H. The coordinate of G here is what? 5, minus 2. The coordinate of H is given as 1, minus 5. Now, if we take a close look at this now, you can see that the direction is G going to H. So we have GH means it is G going to H. So G is the initial, H is the final. With that done, the initial has a coordinate of 5, minus 2. The final has a coordinate of 1, minus 5. So we can call this x1, y1, x2, y2. Therefore, in simple terms, the GH, alright, the vector GH, x2 minus x1, y2 minus y1. Now x2 is equals to what? X2 is 1 minus x1, which is 5. Likewise, y2, which is minus 5, minus y1, which is minus 2. Alright, so solving this now, we have 1 minus 5, which will give us minus 4, minus 2 minus minus 2, and this will give us minus 2 minus 5 plus 2, which will give us minus 3. So we have on the x-axis we have 4, on the y-axis we have 3. Now let's solve this. Now let's compare this using a quick form, a shortcut. Now let's look at this. X 1 2 3 4, y 1 2 3 3. Okay. 1 2 3. Now because it is direction is going downwards, and when it is going downwards it will have a direction of negative. So the x-axis, which has a magnitude of 4, and since it's going downward it will have a direction of negative, which makes it minus 4. And in the y-axis we have a magnitude of 3, and since it is going downwards we'll have a direction of negative, resulting into minus 3. So the vector GH is simply minus 4 minus 3. Yes, so we are now familiar with the two methods. We have the long form, and then we have just the simple method to evaluate it. Now we have IJ. So in this one, let us just use the simple method to evaluate it. All right, so we'll just look at how much distance has it covered. So here it has covered how many? Magnitude 2, and from here to here it has covered a magnitude. Okay, it has covered a magnitude of 1 2 3, which is 3 4 5 6 7 8. Let's cover the magnitude of 8. Now it is going upwards, and it is upwards. If it is upwards, if the arrow is upward, is positive. If the arrow is downwards, is negative. Therefore, we are saying that the vector IJ has the vector of 2 on the x-axis and 8 on the y-axis. And since it is upwards, positive, positive, I just choose to write it as 2, 8. Now you can also choose to confirm using the long method that we have here or here, and I assure you that you get the same answer. Now yes, we have solved exercise 1, and I believe that you were able to get the correct answers. So let's move on and let's see how to implement this thing in the next video.